So today we're gonna start a new chapter which is known as atomic structure and nuclear chemistry. So first of all, what is atom? Atom means which is it is made up of A plus term, A plus TOM. A means non, T means divisible, which is non-divisible. That was the initial definition which scientists proposed about the atom. So first of all, Dalton atomic theory came. The human is always a curious person. So he always want to know what is the tiniest particle look like, how does it look like, what is its structure. So in order to know that, a lot of scientists came in the sequence and they start giving their own theory. Some points were okay to digest and some were totally rejected by the other scientists. So a lot of theory we're gonna study in this chapter. First of all, we know structure of atom is first of all Dalton atomic theory has been studied in previous topics. So here we want to study Rutherford model, Bohr atomic model, and wave mechanical model of an atom. So what is Rutherford model, and what was the earlier efforts that were used to reveal the structure of atom? First of all, what happened? Let's study what happened initially. Initially, scientist name Julius Plucker. Julius Plucker in 1859. What happened? Julius Plucker in 1859 was studying the conductivity of a gas. We all know that the solid always conduct electricity, solid metal always conduct electricity due to flow of electron. Liquid conduct electricity due to flow of ions. But does gas conduct electricity? We don't know. If we apply 2 ion on the gas, then there is not necessary that current will flow. We don't know. We know that current will not flow at a normal temperature and a normal pressure actually. So what happened here? It was a cathode and here there was an anode. Okay, here it was a cathode and it was an anode. And the voltage, very high voltage applied, 10 to the power 4 volt was being applied. 10 to the power 4 volt was being applied. So when the volt applied, the pressure of 10 to the power minus 4 atm was observed, was created by a vacuum pump, and a cathode and anode was made. So when a high voltage applied, so a ray seems to be generated from cathode to anode. A ray was observed for passing from cathode to anode. A ray was observed. How is this possible? We know that when we apply the electricity among the gas, it doesn't flow. Electrons doesn't flow. Electrons no. We know that conductivity does not happen. It is not a conductor. But at a very low pressure and very high voltage, the electricity was passing. Means some ray was passing. Okay, that was invisible ray. And due to we apply the zinc sulfide over in the below, back ZRS, zinc sulfide screen, then we see it illuminates. It illuminates. Okay. So in 1859, Julius Plucker was doing the experiment, and an invisible ray that seems to be generated from the cathode side has been named as a cathode ray. So what the property of cathode ray? When a metal object is placed on its path, a shadow appears. Okay. So means it is traveling in a straight line. If we apply a pedal on its path, the pedal starts rotating. That means it is made up of material part. Okay. When electric and magnetic field both applied, it deviates from its path. That means it has some charge. Okay. So it has a glow appears when it's applied on zinc sulfide screen. Aluminum, it affects the photographic plate. Okay, the E by M ratio for all type of gas. If we fill neon, helium, hydrogen, if we fill neon, helium, any gas we fill, oxygen, hydrogen, helium, any gas we fill, the E by M ratio of the particular E by M ratio will remain same. Charge upon mass ratio of that particle, cathode ray, will remain same. So what happened? What happened inside the tube? Actually, when we apply a very high voltage, let's say we have applied hydrogen will get ionized. It will form H2 plus electron. When we apply oxygen, it will go O2 plus an electron. When we apply over voltage over the helium, then it will become He plus an electron. So every time the electrons is released, electron is released. So in this container, what happens? Helium plus, when we suppose we have filled the helium glass, helium plus and electron are there. So helium plus will move from negative to positive side, and positive to negative side, and negative to positive side. Anode will, that electron will go. So it doesn't matter, whatever the gas we have chosen, the electron will remain electron, and it will go, the electron will remain electron. Okay. Now again, the Goldstein in 1886 observed a anode ray. Now that the discovery of proton happened, as I discussed, that when oxygen is get ionized, O2 plus electron comes. So electron goes from anode to cathode. But from O2 plus is also there. O2 plus is also there. It will go from cathode to anode. It will go from cathode to anode side. It will go from cathode to anode side. So if we fill the helium gas, it will also go from cathode to anode side, and electron will go as a cathode ray. This will form anode ray, and this will form cathode ray. So cathode ray, all E by M ratio same, but anode ray E by M ratio depends whatever the gas we are filling inside it. Okay, the properties of anode ray and cathode ray are similar. Just it also travels in a straight line. It also deviates in. It also flow. It also rotates the pedal. It also is made up of material because it forms the shadow. Okay, and it rotates the pedal, as I previously mentioned. But here the charge upon mass ratio depends which type of gas we have chosen, and the charge upon mass ratio is maximum when we have chosen hydrogen gas. When we have chosen hydrogen gas, and Q by M ratio is maximum when we have chosen hydrogen gas, and that particular matter is called proton. When Q by M maximum, that particular matter is called proton. So here it is written, for different gas used in a discharge tube, E by M ratio positively part is different. When hydrogen is taken, E by M ratio is found to be maximum. So lightest particle is called the proton. Okay, so we have studied the discovery of electron and proton. Now we have studied the discovery of neutron. We will study discovery of neutron. What happens? James Chadwick in 1932 was bombarding beryllium on helium. So he observed a massless particle coming out of that, which is not massless, chargeless particle. A neutral particle was coming out, and he named later them as a neutron. So in order to describe the in atom, first of all, they already know what is electron, proton, and neutron. They already have discovered what is electron, proton, and neutron. So that's all about the theory of electron, proton, and neutron. The charge, the mass, the discoverer, the charge, mass, and discover, mass, charge, and discover. This is the list of their owner.